Hey, how you doing? My name's Angela McCall. Welcome back to Point and Click Puzzle Games. Now, it's been about 2 years since I last released a video on this channel. Life's been busy, but where I have been sort of working my way up to sort of doing some more content, one of the things that I've done is I've looked through my channel. People have requested that I do a little walkthrough series for complementing the actual tutorials that are available on the Solar2D website. So this video right now is all about chapter 1. It's doing a walkthrough of the tutorial and getting you guys back up to speed. So I'm going to presume if you're following this video, you've installed Solar2D and you've got a text editor ready to go. So the first thing we're going to do is jump over to my left-hand monitor, where you will see that I'm ready to go for a new project. So I'm going to click on that button there. I'm going to call this My Balloon Tap Game. If you have a look here, browse to this location, make sure you know how to find this folder. The default setting is that it's gone into my documents for Corona projects in the future, so that's fine, and that it's a blank game. It's in the upright position, and we're going to click on OK. And then what's going to happen is lots of things. First of all, clicking on OK has made my Visual Studio software where we're going to write the code appear, which is great. Then here we have got the actual, I've got 2 versions. I'm not sure what that has. Let's get rid of that one. Then we've got my Windows Explorer. So now we can see here, there's my Balloon Tap game, and it's inside Corona projects, and there's all the files that are automatically given as part of the game creation. So we're going to need this location in just a second. We've then got the little actual real world sort of simulator, so that's cool. We'll put that above my head just there. And then one other that it is open but it hasn't shown up there is the behind the scenes. Now, just opening and creating a new game has given all of these sorts of commands and input in the back end. So if you think of this as the human view and this is the brain, on the left hand side, this simulator console. So this is what we see, but this is what's going on behind the scenes, as it were, behind the curtain. So the first thing we're going to need to do is find the Solar2D website so that we can follow along with the actual tutorial. Okay, so we're going to go to documentation, and then we're going to go to getting started, and we are going to go to creating our project, the first one. Now, the first couple of lines here is telling you all about needing a text editor, which is my Visual Studio there. Again, Visual Studio is open source, and there is a video somewhere on this channel explaining how to use that somewhere in the back end from a couple of years ago. Now we're going to create a new project. Now, the first thing you're going to need to do is down here, it says the chapters source files are available for you to download. If you click on that, it's going to give you a zip file. You just need to go and unzip that, and you're going to need to know where those files are, because you're going to need to put them in just a moment back into there we go, Corona projects. I've just clicked on that, that's the zipping bit. But if you go into your Balloon Tap game, you're going to need to put some of the assets, the images, in here in just a second. So I'm going to leave that just there. Right, okay. The other thing that you get in this actual downloaded zip file is the code, the actual completed code, but we are going to write that, so you can download it if you want and then compare what you write to that, but obviously it's going to be on my screen for you as well. So the 3 images that you're going to need is a background, the platform, and the balloon. So if we look back up here, the background is this blue cloudy looking image here. Obviously the balloon speaks for itself, and then the platform, that basically represents the earth. Okay, so loading the background, so our first bit of code. Now I'm going to copy and paste for speed, and then I'm going to work you through what that means. So we're going to go to our Visual Studio. I'm going to delete that line 7 and I'm going to paste it. So if you look here, we've got lines 1, 2, 3, 4, 5, 6, 7. Quickly giving you an orientation of the game here. We've got the file name, we've got the app that we're in, so that's the Balloon Tap, and this is our first line of code. So what it's basically saying in this green up here, these lines are green, are comments. So we can leave ourselves instructions or notes or little hints for the future, but it's not actually part of the code that formulates the game. And then we've got this line here. So from left to right, it says local, which means that this code is only going to work in this file. When you have bigger games in the future, they will they will be made up of many different files. So it's a way of sort of making sure the code stays local to one particular file at a time. We've got a variable called background. That's like a big old box in which at the moment it's empty. And we're going to put in the command to put something on the display, which is an image rectangle. And we're going to put that image with the width and the size. They're not pixels, they're kind of like units, but essentially if you think of it as pixels, it's the easiest way to get your head around it at the moment. Because mobile apps could be screens of all different sizes, and they can also go on tablets and all this, that and the other, they all use different size units of imagery, and we refer to them normally in graphic design as pixels, but they're not actually called pixels in the environment we're working in at the moment, but it's the easiest way to get your head around it. Now if I hit return, nothing's going to happen just yet, except I've created a new line, and then you can see here there's a little white dot saying that I need to save the game, so I'm going to hit save. But as I said, nothing is going to happen just yet. You can see that the screen is still blank. The reason being is that at the moment Lua is looking for this file called background PNG, and it's expecting to, let me just bring it up on screen, it's expecting to find it inside the folder My Balloon Tap Game, which is where we're telling all the files exist. But as you can see, there is no balloon.png file here. Now I happen to have downloaded and unzipped these beforehand, and for speed of ease, I'm going to copy all three of those right now. And I'm going to go into my Balloon Tap Game, and I'm just going to dump them there. So now you can see that the three files exist. If I shrink that down and then I come back and resave the game, it loads. Now obviously it's not looking quite like it did on the tutorial page. If we go back up here, it's a nice full image, but we will get to that in just a second. So let's scroll on down and see what's going on here. Okay, so we're telling this to display at 360 by 570. Oh, where's it gone? Bear with me a second. 360 by 70. Obviously I've got this set up at the moment as a bigger screen, so I'm using this simulator as if it was an iPhone X. They do need to update this and bring this in a little bit more, but an iPhone X screen is more or less the same size screen as most of the mobile phones that are around at the moment. So obviously not quite matching, but we're not far off. At least something has positively happened. Now all of this down here just pretty much explains what I've just walked you through, so if you read that as well, that will help you out. Now moving down here, we've now got two lines of code on line 8 and line 9. I'm just going to copy those, and if you look, it's copied this word background and it's got an X and a Y, so we're just going to add that into our code right now and walk through it. So it's basically creating this object, or this variable called background, at which point now it knows it's using this image, but it's now got to position it on the screen. So if we looked at our little demo, it's positioned it right up in the top left corner. Okay, so if you can imagine, obviously there's a curve here, but if that was a straight line going over, the point would be about where the tip of my cursor is right now, and that position there is 0, 0. Okay, so if we come back down here, it'll explain in a moment that when things are positioned, they start in the top left corner. But what we want to do is we want to center it on the screen. Okay, so to do that, we then have to say display the content center X, which means the X is going widthwise horizontally. So halfway across this screen will be somewhere around here where I'm moving my cursor, and then obviously we want it somewhere to be in the center on the Y, and the Y is the vertical axis. So again, somewhere between the top and the bottom is going to be about here. So if we hit that and save now, then you can see that it's repositioned. Now the only tweak that I'm going to do here is these sizes are a little bit, there's a black bar at the top and a black bar at the bottom, so this is a good way to just sort of have a play around. Obviously it's going to distort the image just a little bit, but given it's just a background and I want you guys to learn how you can tweak things, I'm just going to have a little bit of a cheat and save it so that now the image is fully covering the background. There are other ways that you would do this more professionally if you was building an actual app because of the different size environments, but for now, just so that you've got something to work with, that's the way we're going to do it. Now let's go back over to our code. So over here we've now centered it, we are, there you go, that's where it's explaining the point up in the top left corner, and we need to actually say no, we want it to go in the center, which is fine. So the next thing we need to do is we need to load in the platform. So to speed things up, we're going to copy this code again, and we're just going to walk through how it changes. So next line down. So again, we're telling it it's local just like before, and this time we're creating a platform. We're using the same command, so display a new image rectangle, different sizes, but there's the file name. This time we still want it to be centered evenly between the left and the right edge of the screen, but we want it to be positioned nearer the bottom. So we're looking at the height of the entire screen and just a little bit before it gets to the bottom. So let's see what happens when we hit save now and bring that back up on screen. And there you go. There is our platform. Now it's not sitting right at the bottom because when this code was designed, it was for a different sized screen, but we get the gist. Okay, now what we could do is we could move and play around with that number. Let's say if we went down to 100 and save, you can see it moves up, and if we left that as a plus 100, save, we can hit return, and it's now right at the bottom. Now you might think, why is, if it's going up and down, it's going the wrong way? That's because in the Lua environment, we use things in an opposite dimension to what you would have been taught at school in maths. So in maths at school, you would have been taught a coordinate system called Cartesian. Okay, I think it's based, don't get my history right, but I think it's based on the Greeks. But essentially, the up and down, shall we say, on the y-axis would have been positive anything going north and negative going south. So if I'd have put negative 100, we'd have started at 0 and we would end up down here. However, in the Lua environment, just to confuse us, it's all the other way around. Again, I've actually done a whole tutorial on this in one of my videos from about 2-3 years ago, so I'll put the link up above. But that's essentially why we put minus 25, so that we could say there's the bottom with the content height, and we just need to lift it up a little bit above that. Okay, so going back up the screen here, we are going to go back to, there's our platform. Okay, so now we need to load in the balloon. So again, we're going to use the same command, this time for a balloon image. There we go. I'm going to scroll on down, and again, it's exactly the same command. You're used to it by now, but this time, because it's a square image, it's the width and the height are the same, and we're going to position it dead center on the screen again. Okay, and there we go. We're going to add another line of code in here called alpha. Now, alpha is the fancy word for saying transparency, essentially, when you are dealing with images and graphics. And it's always designed from 1 being 100% solid and 0 being 100% transparent. Okay, so we use it in decimal places. So if I was to go 0.5, that would be like saying 50% transparent, 50% solid. Okay. We are using the word balloon because this is the variable that's holding all of the information about our balloon object here, and the alpha is just the command for transparency. So we're saying on our balloon object, turn its transparency to 50%, or in this case they had 0.8, and that's because in the real world, when you blow up a balloon, they're not generally solid articles, they're kind of like semi-translucent, so that's what they're doing. So save, and you can just see now that that turned a little bit bluer, and you can experiment if you want. If we go 0.1, save, and then you can see there it's almost completely invisible, and you could make it 1 if you wanted to, at which point that kind of removes the need to actually write alpha. And we're going to go back to 0.5, and then you can see there it's 50%. So just to keep things the same as they are on the game, we're going to go back to 0.8. So there's another little way to experiment there. Okay, so moving on further down, now we're going to add in an engine called physics. Now think of physics as somebody already having written an entire library of commands and code and situations to help you simulate the real world of physics. So you know the whole dropping an apple, where does it go? It falls down to the earth. That's because there's gravity, and all of that is to do with physics. So this here is what we're up to right now. So on line 20 and 21, we're now going to load in an entire library that has already been existing inside the Solar2D environment, and we're going to start it. So not only are we going to add it to our game, that we're going to start it running, just like you start a car engine. The engine still exists, but it's either turned on or turned off. So this is what we're going to do right now. Okay, and that just explains it in a little bit more detail. Now, when we are dealing with physics can have different states. And what we're going to do is we're going to tell our platform that it's basically the ground, okay, which means it's static. The ground doesn't move. A balloon moves about, but in relation to the ground doesn't move. So we're going to add now physics. So we're telling to add physics to this object platform, okay, but we're giving it the word static because we don't want the ground to move. Once the ground is there on the screen, it is permanently positioned and nothing can go through it, nothing can move it around the screen, etc, etc. The next line of code is pretty much similar sort of thing, but what we're doing this time is we're adding to the balloon a dynamic status. And obviously when you play a game with your kids and you're hitting the balloon around, it floats up in the air, it bounces down to the ground, etc. So the first thing we're going to do is tell the balloon object that it is dynamically able to float around and move about. But how exactly does the game know what is the balloon on screen and what's not? Well, we have to give it a radius of 50. So think of it as like a big old round coin on top of that balloon, and we're going to give it a bounce rate of 0.3. So the radius basically is a way of, the radius is basically a way of saying this is the actual part of the balloon itself, okay? So if we bring that back up on screen here, there we go, bear with me just a second. That round 50 is essentially saying wherever the balloon is, that is the area. If we'd have made it 100, it would have been over here, and obviously clearly where I'm circling my cursor right now was be way past the scope of what we want to be the balloon. So by saying 50, it's more or less covering that balloon object perfectly. And then a bounce rate of 0.3. So down here it does explain that as well. If you have a bounce rate of 100, or that would be the equivalent of setting as 1, then it would be as wherever you drop the balloon on the screen, it will bounce and come straight back to that exact same position. That's 100% down and up. 0.3 is like saying 30% bounce. So when you drop the balloon, it's going to go down, but it's only going to come back up about 30%. So that's why we use the 0.3 again as the decimal places, just as before. Okay, so that's what the 0.3 there is. And I'm going to hit save. And then obviously when we do this, we can see that the physics has now been applied, it's kicked in, and the balloon has dropped. But obviously nothing's happening now that the balloon is at the bottom of the ground. It's not gone anywhere because we haven't given the game any instructions as to what to do when we tap the balloon. It doesn't even know that we are tapping the balloon at the moment. So we need to write all of that code to listen for a tap and basically make the balloon move when we click on it. So that's what we're going to do moving further on down here. So now we need to actually create something called a function. Now the reason we create a function is because we might tap the balloon more than once. Now it's something that's worth explaining here. Lua is a linear process when it reads in the code. Now, just like when we read a book page, we start at the book, top left corner, and we read across the line, and we read in the next line, and as we read in, we take in the information and we learn what the page is telling us, whether it's a story, whether it's a textbook for school. We read from top to bottom, left to right, and as we learn this information, it's going into our brains. That's exactly how a linear programming language like Lua works. So when Lua loads this game, it's literally starting in the very left hand side of line 1, and it's learning that that line there is a comment, and then a comment, and we've put in some text, etc., and then it gets to the code and it reads in line by line. So the first thing it's learning is that there is a background to display. Then it's going to display the image for the platform and then the balloon. Now the interesting thing here is, and this is the way that you can test that you understand what's going on with the linear process, is that if we moved these three images into a different order, they will still exist, but we might not be able to see them the same way because they're layering up like it's bits of paper on top of one another. So for example, if we was to put the background as the third item, and I'm just going to comment out up here, okay, and hit save, we can see that everything's disappeared. They haven't technically disappeared, it's just that the first item being the first item being positioned on the screen there is the platform. Sorry, there's the platform. Then we are putting the balloon, but because the image for the background is so big that it covers the entire screen, when we put that on top of that, it hides everything underneath. So think of it almost as little cutout bits of paper on your desktop with the platform now, with the background being on top. You can't see the bits of cutouts below, which is why when you put things, when you code, the order in which you are coding is actually really important. So I've just commented that out and I'm just going to uncomment that. So everything's back in the right way. And there we go. There's our balloon dropping once more. Okay. So now we come down to our function. Now, our function is, think of it as like a sergeant major barking out the same command to you time and time and time, like drop and give me 10 push-ups, drop and give me 10 push-ups. Instead of saying that every time and writing the code every time, what we do is we write the code once and we call that function as many times as we need for it to execute. Okay, so what we have to do now is we actually have to tell Lua, because of this linear process, when it gets to code that we're writing down here, how, if it starts from top to bottom, how's it going to know to go back up and read? Well, that's what the goal of a function is. It means that actually it's almost like taking it as a separate little bit of code and just saying, anytime I call the word push balloon, go and reread and execute this code. So we start by saying local again telling it that this function only exists inside this file. Obviously, we've got to name it as a function so that Lua, when it's executing code way down past the bottom of our screen, it knows to jump back up, quickly read this, and then go back to where it was. And then obviously, so that we can identify it, we give it a name. Don't worry about the two little brackets at the moment. You'll understand those in other tutorials. But obviously, where the function starts and ends, so that when the code has executed, it knows to continue doing what it was doing before it had to quickly go and do this. Right, so now we are going to add some impulse to our balloon. So when it's tapped, it moves around the screen. Okay, so that's what this line of code is. So I'm just going to copy it and paste it again, just like you guys. And the code, let's walk our way through it. So first of all, what we're not putting it on the platform. We want the balloon itself to move. So we obviously have to name that object. Then we want to apply it in a linear motion. So linear basically means a straight line. And we're going to give it some impulse, which is like pushing it forwards or upwards or to the right or to the left. It can't go round in circles. It can only go in a straight direction. We've then got our x-axis, which means go side to side. So are we going to move the balloon from the left to the right, to the left, to the right? The answer is no. It's going to be 0. And then we have the next next detail, sorry, I couldn't get my words out. The next details there, which basically says that we're going to move it on the y-axis, and it's going to be 0.75. So it's just going to move it just a little bit. And again, you can play with these numbers. And then we're going to position the balloon inside the balloon. Where does this start? It's on the X and the Y. Okay, so I'm just going to save that again. And when we do this, it's still nothing's happening, even though we're telling it to move. Why is that? That's because we've not told the balloon to listen for us to tap. Okay, so we have got to come back to our code over here. Oh, there you go. That's where it explains about the amount of force. That's the word I was looking for. Right, okay, so now what we've got to do is we have to add this line of code here, an event. So just like we have ears to listen when people call our name and we can react to that, we then know that we are needed somewhere. Exactly the same thing happens with objects that we are creating, okay? So we have to give it a set of ears, essentially, so that when we call push balloon, it knows, because we've already assigned it to that object, that it itself is needing to do something. So we're going to add to the balloon an event listener. That action is tap. So when I hit one quick tap, not a drag, but when I hit the tap on my mouse, on my key on my mouse, it's then going to run this set of commands, which is push balloon. So basically, even if we've got hundreds of other lines of commands down here, okay, it doesn't matter what happens in the game. The moment the balloon gets a tap, it's going to come up in the code and execute that line of code, and then it's going to stop. So we're going to hit save because our little dot at the top tells us we haven't saved the code. All right, so our balloon has fallen. And now when we click on it, it's going to tap. It's going to move, and you can keep tapping it because whenever you tap it, it's going to make it go up by 0.75. Okay, now to give you an example, what we could do is play with our code and put that as 0 and make this minus 0.75, and you can see what happens then. And this time it's going to move to the side. Oh, and it's gone off the screen. So I can do a quick Control R to refresh. Maybe 7.5 is too much on this, so we could go 0.2. Let's see what happens. And we move it to the left. Oh, is it going to stop? No, it's going to go off the platform. And as you can see, it actually fell off the platform because this is kind of like a platform floating in the air at the moment. Obviously, we'd need to stop it moving that way. So let's refresh that again. And then you can see that I can hit it and I can hit it and I can hit it. So that's basically how you can test it. If I take away the minus, it's going to be a positive, and it will go to the right hand side. So there we go. That's your left and your right. Okay, so let's turn that back to 0. Let's undo all of those. Now remember, the reason that this is a minus is because if we look back up here at our platform is the blue line, and we want it to go up, so it needs to be a negative number going above the platform. Okay, so that's where we are at up to now. On our tutorial page here, it kind of then gives us a summary, so you can compare what your code looks like to that, and then it gives us an extra credit. Now if you look back at the top of the game, where has it gone? Up here. Oh, sorry, it's got the number 11, and that's because it's going to count score now, how many times we hit the tap. So extra credit, where are we? There we go. So we are now going to have to create another variable called tap count, and obviously we haven't started counting, so we need to set that to 0 so that there's a starting point. And so we're going to put this right back at the top of our code. Remember, everything is read linearly, so if we was to put this underneath where we were tapping, then it's not going to know what number to start counting from. So the first thing we have to tell the memory is that we are going to start counting from 0. Okay, now what happens is we need to give it the power to understand when to count. So I'm going to take all of this and we're going to talk you through it. Okay, so then what we need to do is we need to give the game the ability to actually put text on the screen so that it can report the game score to us. So after we've done the background, remember it's got to go in the order that we want things to load on the screen, otherwise they'll be hidden behind the background. So we're going to create a text object, or a text variable rather, that is local to this game. It's going to be a display object because it's going to live on our screen. It's holding text, items of text. So this one up here was holding a rectangular image, and this one's going to hold text. It's going to report the number that lives inside this variable tap count. So this is where it's counting in our memory, 1, 2, 3, 4, how many times we tap the button on the balloon. So it's going to report whatever that number is, and we're going to display that. We now have to position that text on the screen, and that's what this is here. So we're going to display it, obviously nice and center on the screen. Where's my game gone? There we go. So we need to put it somewhere nice in the center of the middle at the top there. So that's what the display X is. We're going to position it halfway between the left and the right of the screen. 20 means we are going to position it 20 points from the top of the screen, and native is just saying we're going to use whatever system font it gives us. Just go with the normal font, and it's going to be size 40 pixels or 40 points. Okay, so now we've got our text. Okay, and then last of all, we need to give our text a color. Right, before we do that, let's just save and see what happens. Where's our game gone? Where's our game? There you go. Now we can see that the 0 that we've just put in there works. In fact, we could put in there test, and obviously because it's text, it has to go inside quotes, but if it was a number, it didn't need to. So I can hit save, Oh, hit save. Why is my game not reloading? There we go. Relaunch. There we go. I don't know what was going on there, but sometimes I was doing Control R on the keyboard, but sometimes you can need to relaunch. That's fine. It starts afresh. There's our word test, so you can put whatever you want in there. So hello, save, and then it changes, but we're going to go back to the number 0. There we go. Our 0's on screen. We can change the color of it. Let's have a look. This is what we're saying here. So copy the color. So our object, there's our text object, the line underneath it. So we're going to take our variable text, tap text. We're going to set its color of its text to 000. This is the RGB values. So R is either 0 or 1 for maximum red, G for green, B for blue. And again, it's the decimal point system. So if I was to put 0.5, it's going to be somewhere between the red, green and blue values for that color, which is a gray. There we go. We've turned it gray. So you can experiment essentially. If I turn them all back to having no color whatsoever, there we go. That's representing black. And if I was to turn all of those to 1, so it's 100% of the RGB value, there it's how we make Y. And then obviously we can play around. So if I was to leave 100% on the R, which is red, and then 0 on the blue and the black, we would get a red number, and so on and so on and so on. So that's how we can play around with our colors. I'm going to leave it black. There we go. So we can see it nice and clearly. Now we've got our text reporting. Obviously, if we play our game and I keep hitting it, it's not actually counting anything at the moment. And that's where, oh, you can see this, the translucent alpha. Look, there you go. You can still see the number underneath it because we've got it as 0.8 translucent. There we go. What we need to do now is we need to actually give the ability to update that counter and basically count. So when we tap, so obviously our balloon is waiting for it to be tapped, so we move it, we can put in here. So we're going to take the number 0 and we're going to add 1 to it, and then we're going to save it back and overwrite what was in the variable. So now our variable holds the number 1, and then we're going to put that number 1 inside the text of our tap text variable. A little bit complicated there. So I hope you get that. Essentially, let's do that once again. So whenever we are writing code, we assign the things on the right side of the equal sign and we stick them in the left hand side. So when you write maths at school, it was 3 plus 3 equals answer. In the coding world, we do answer equals 3 plus 3. Okay, so whatever we're assigning on the right hand side has to go in the left. So we're going to take, so that we load our game creates a variable called tap count and assigns it the value 0. So tap count is now floating around in memory with the answer 0. We're going to grab this tap count 0, we're adding 1 to it and overwriting, so now tap count holds the value of 1, but now we need to tell the computer screen to update the text on the screen the moment we've hit the tap. So we take that 1 and we overwrite the text on the screen. So remember that object here has a text. Now obviously we didn't do a dot text up here, but because when we created the object we told it there to write whatever was inside that variable, that's where it's picking it up. So now we need to over correct that, which is what this tap text here does. So we're going to hit save. We're going to bring our balloon back on screen, and now when I hit the balloon, it's counting 1, 2, 3, 4, 5, etc, etc. So we know that our little tap count is working. Okay, so that pretty much brings us to the end of this particular game and our first chapter. All the different concepts that we've discussed are actually available for you to learn more about it in the documentation. So we used a display new image. Let's bring that back up on screen. Let me move this over. So we've got a display new image command there. that teaches you how to learn about it. Object X, so we had an object, so that's our object background, and we've given it its X value. We've had an object called platform, given it an X value and its Y, the balloon, etc. So that's how we learn about the X positioning and Y positioning. We've got display content center X, and we've got it somewhere else. There we go, content center Y. We've got our alpha, so you can learn more about that. Requiring in, that's for our physics engine. Where's it gone? That's our require, and then the bracket. So that's how we require in other libraries of code that's already been designed for us to use. We've got the physics starts command, adding a body to an object. So these are our objects, but now it has a physical body, so nothing can move through it. We've got the impulse and the listeners, and new text and fill color. So everything that we've learned, you can go and read more about on this page. So for example, I could go and click on object alpha, and it will basically tell me everything about that command with an example at the bottom. So it belongs in the number family. It's an object for the screen. It goes on the display library. Tells you roughly what it does there. There's some little catches, things to watch out for, things that you might not be aware of. And then you've got some real life examples. So if you're struggling, you can always copy this code, put it in your app, and then give a test based on what it's doing. So there we go, and that's the end of today's tutorial. So it's a bit of a long one, but there's a lot to go through for the very first time when you're touching things, because it can seem really overwhelming. And what we'll be doing now is going on to chapter 2 if you want to follow along. If you like this video, don't forget to hit the subscribe button and the bell to be notified when I release new videos in the future. Thanks very much for watching.